Hello everyone, good evening to all. Welcome to Unacademy, which is the biggest online education platform for GATE, Computer Science and IT. And here myself Malaysian Devasane. You can call me as Deva sir. And here I'm going to teach theory of computation, compiler and C programming on this channel. And let me introduce myself. If you are joining today the first time, please let me introduce. I have secured all India rank 119 and 210 in my BTech third year and final year with self-preparation. I have completed my Masters from IIT Bombay in Computer Science. Then I started teaching GATE classes, where almost I have 12 years of teaching experience in taking the GATE classes. And I have experience in many subjects in GATE. Here I am going to take 3 subjects on the channel. This is my referral code. If you are interested for taking the subscription on Unacademy, please use this code DEVALIVE to get 10% discount, as well as you will get guidance from me. That's a more important on Unacademy. Guidance is the crucial to crack the exam. If you are watching this video, please like the session and also share with your friends so that they may join the session too. This is my URL on Unacademy. You can access all my classes, free classes from this URL. You can watch and you can attend live sessions. And if you follow me, click on follow so that you will get regular notifications whenever I take the classes. So these are the classes mainly I take on Unacademy: C, TOC, Compiler Design and Top, and sometimes I may deal with other topics from other subjects too, so that you can access to them. So what I do basically on Unacademy free classes, I will conduct some practice in new questions. That's more important when you study any topic, and you will also get the topic wise explanation for you, special classes, and you will also get a revision on each topic that I discuss. And you will also get a practice on GATE previous year questions, and you will have the all 12 subjects in one session. Also sometimes I discuss, so practicing mini GATE questions, right? Every subject one question I may take up sometimes. So these are the main classes that I conduct free sessions on Unacademy. So you can visit my profile and you can access to all these classes to learn. More than 300 classes. Each class is 1 hour minimum, so more than 300 classes are already available. You can access them. And why we asked you to join Plus if you are preparing for GATE exam, because there are various benefits on Unacademy Plus subscription. You will have live lectures, you will have live test, and you will have a crash courses, and you will have doubt solving separate courses are there, and rank improvement batches, revision batches, and so many are there on Plus. We have 2 kinds of plans or subscriptions, Iconic and Plus. Plus all are structured, which are live classes or live tests, all are structured and scheduled properly. Iconic, you will get all benefits of Plus. Additionally, you will have a coach to guide you, you will have a plan, you will have guidelines to follow. So these are the, today the price is going to increase after this class. Maybe by 6 p.m. the prices are going to increase. If you are interested, you can take the subscription before 6 p.m. today. So today's price till 6 p.m. is 22,500 for 1 year plus subscription. But Iconic is 40,500 for 1 year after applying the DEVALIVE code. If you look at the prices that are going to vary from today, just after 1.5 hours, the prices are going to increase. 12 months previous price till now 22,500, but after 6 p.m. it's going to be 27,225. For 2 years plus subscription, 27,000 after including the code DEVALIVE I'm talking about. Before, if you don't apply the code, it will be already 30,000. Now this will become 39,600. So more than 12,000 is going to increase for 2 years. And you can choose the payment method, credit, debit or net banking, even no cost EMI. There are facilities of part EMI so that you can read PDF while paying the amount. We have a Facebook group. Please, you can join this group to get notifications from us, GATE aspirants. And we also have a Telegram channel, Unacademy GATE CS, so that you will get notifications from us regularly. And you may or may not aware of our YouTube channels. We have so many YouTube channels from Unacademy for various engineering streams like electrical, electronics, instrumentation, and then mechanical, civil, production, and you have various channels here, so you can share with your friends. Guys, please like the session. If you are watching this video, we are going to begin our class. Like the session, and also please subscribe if you have not done, and also share if anybody want to join these classes. Yeah. Let's begin today's undecidability second part, where actually we have not started even one definition of undecidability 2. But what we have done in undecidability first part, previous session, we have understood the importance of complement operation. Like if anybody asks now, what is the recursive language complement? You will say it is recursive. If anybody asks what is RE complement, you will say either recursive, it depends on the problem, or not REL. These are the two important properties, and there's one more property, that is if anybody asks RE but not recursive, if this language complement is going to be not RE, and I'm going to repeat that too today. Yeah, so that was yesterday class. If anybody is not there, you can watch yesterday class. And the second, we have also learned synonyms of each word, like decidable you can call a recursive. Another name, you can say Turing decidable, or you can say effectively enumerable, lexicographically enumerable, right? So we have learned so many names for decidable, semi-decidable, RE but not recursive, undecidability and not RE. Right? Today what we are going to talk about, and let me write important name. Semi-decidable, what is another name? RE. Right? RE. So recursive is also called as decidable, and RE also called as semi-decidable, recursively enumerable. So today we are going to look at the definitions and examples. That means there is so much to understand in this undecidability chapter. First, remembering the words are very important. Then once you remember the words, definitions will play a lot of importance before starting any example or problem. I'm going to discuss together definition and example so that you will have a clarity between the two things. And I'm going to look at the first three are very, very important for me, because if the answer is decidable, you can say even it is semi-decidable, because every decidable is semi-decidable. And RE but not recursive, you can say semi-decidable, or you can say undecidable. And not RE, simply you can say undecidable. So if you know the answer for the first three words, then the other two words automatically can be derived, right? Yeah. And once we understand definitions today, if we are able to complete these definitions, we will move next to topic either today or tomorrow, decision problems or decision properties. What are the problems are decidable for this kinds of two machines, or we can also go for languages. Yeah, we have so much of problems or so much of trouble in understanding the problem and language. So I want you to understand the two things separately, so that whenever somebody asks a question, you can easily answer them, right? So what is a problem? What is a language, right? So if I ask, is given DFA accepts particular string, I am asking AAA. a kind of a problem, the answers will be there either yes or no. What is given here? Two things are given. DFA given, string is given. Only what you have to do you have any algorithm to verify? Do you have any algorithm to verify that AAA is accepted by DFA or not? If it is accepted, we say yes. If it is not accepted, we say no. This is called as a problem. This is called as a problem. We can't just say language now. It is just a problem. What you can say, this is a problem. Problem always has two things, either yes or no. Right? If both you can able to answer, then that problem you can say something. We'll see that slowly. And another one is language. Like, I want to say L is equal to I'm writing language epsilon A double A. It's a language. Or I can say L2 this is also language. But language can contain, look at that, a sequence of symbols, right? This is something like, W such that W belongs to A star where length of W less than or equals to. And what is this? Maybe you have a few DFAs only, guys. I've given two DFAs, but that DFA accepts epsilon, maybe. Some DFAs, they accept epsilon. Okay, I've only taken two DFAs, that's all. This is set of DFAs, set of few DFAs only. Set of DFAs, where not all, some DFAs only. That's given to you, where each one accepts epsilon. If I want to collect all DFAs, then so many other versions also going to come. Everybody, guys, look at the difference. What is a problem? What is a language? This is a language. This is another language. But language can be any collection of members. The member can be sequence of symbols, member can be a motion, member can be a grammar too. And some people really do not know what is the language too. I have a collected set of strings, where string is a sequence of symbols, and sometimes set of motions. The motions may have any criteria, and sometimes you may have a language is set of even grammars. Grammar can be context-free grammars or regular grammars, depends on your requirement. And even it can be set of regular expressions. Even I can do that. Suppose I want to write all the expressions where each expression generates epsilon, something like that. Right? Even I can have something different, like I can have a pair where first one will have M, other can be W, where M is something motion, where W is some string. I have a particular condition there. That's okay. Look at what is the language and what is the problem, right? So most of the people believe it. Every language is also a problem, no doubt. But as per our understanding now, the problem is always have a question mark. Something is given to you. We need to answer. We need to decide whether we can say yes or no. If you can say, if this motion accepts AAA, you are able to say yes. If not able to accept, you are able to say no. That means you have a logic for both, right? So always the problem we will think about, do you have a logic for yes and no? And when it is a language, guys, I'm talking about that. If it is a problem, we are going to think about, do we have logic for yes? Do we have logic for no? If both are having logic, then that problem is called as decidable. I am going to talk about slowly, not now. Don't worry about that thing. If it is a language, we are going to talk about, do we have a logic for valid strings? for valid strings. What do you mean by valid strings? Instead of saying valid strings, you can say valid members. The member can be a string that you have studied from the beginning sequence of symbols, but string need not be. Valid members means the W belongs to L. Don't assume W is a string, W is sequence of symbols. W can be a machine also here. W can be expression also. Another one, do we have a logic for invalid members too? Look at guys, how to understand a problem and a language to decide whether that is decidable or undecidable in the future. We are going to define it. So far, even I have not started the definition of decidable too, right? I'm trying to explain what is a problem and what is a language. A problem is like a question. You will have a question where you need to decide, can you say yes or no? If you are able to say yes, that means you will have a logic. You're able to say no for those machines which it doesn't accept, that means no also have a logic. But you are able to say yes, you are not able to say no, that means that's some problem here, that's some kind of problem here. So that we are going to learn now, guys. So I'm going to start today in this first definition, decidable problem. Decidable language, decidable problem. Both I'm going to give a clear definition to understand them. With an example, guys, with an example. So assume this problem is decidable. You might be given some inputs. And here two things we will have. If you are able to say yes, or you are able to say no. Yes as a logic, why we say yes, and no also as a logic because we can halt to decide it. Both yes and no, we are able to check clearly for the given problem that problem is decidable. Come on guys, that problem is decidable. Everyone? Okay, example to understand this, guys. This is the problem I am saying. You are trying to decide something. You might give some input. Input may be one or more, doesn't matter, guys. I've just taken one arrow. One arrow doesn't mean one input here. It could be many inputs. Suppose I want to understand. Example, guys. One example to understand. I have two inputs because I will give you two machines like a DFA1, DFA2. I just want to check is a language of DFA1 equal to language of DFA2. If you are able to say yes or no, then definitely yes. If yes has the logic and no also has the logic, definitely this problem is decidable. Then how can you say yes? Yes means language of DFA1 equal to language of DFA2. Give me a second, guys. Just give me a second. Yeah, thank you. No means language of DFA1 not equal language of DFA2. Everyone, guys, when we say a problem is decidable, you have a logic for yes and no. Now I have a question. Can you decide the given two DFAs accept same language? Right now we have not started it, but I'm giving just a definition example, right? If yes and no, both have a logics. Both have a logics. If and only if problem is decidable. This is our definition here. Now I'm asking for particular example. I'm going to discuss so many problems like this. If I'm saying equal, what do you do, guys? This DFA1, you minimize it, construct minimum DFA1, and for this construct minimum DFA2, and check these two, are they isomorphic or not? If they are having same structure or not. If they are looks same, isomorphic problem is decidable, guys. Even though it takes much time, but isomorphic problem is decidable. Two DFAs, their structures exactly same or not, right? If they are exactly same, because every regular language they have the unique minimum DFA. That is the reason we can convert both DFAs into minimum DFA. If they are isomorphic to each other, that means they are accepting same language. Because for regular language you cannot have two minimum DFAs. Everybody? So that is the reason if this problem is decidable. No means they are not isomorphic. Minimum DFAs are not isomorphic. Not isomorphic. They are not having same structure. Minimum DFAs are isomorphic. That's an algorithm. We have an algorithm. Decidable problem means algorithm exists. If algo exists, you can say yes and no, and you will always halt. The meaning of decidable problem, guys, the meaning of decidable problem. Doesn't matter how much time it takes, polynomial or non-polynomial, but this problem is solved. Algorithm exists for that. That may be solved in polynomial, non-polynomial, doesn't matter to us. Algorithm exists, and algo means it always halts. Always halts. The algorithm always halts, no matter what problem it is. And you have yes and no. Both have logics here. Everyone? And that's a decidable problem. That's a decidable problem. We have an algorithm to decide yes and no. I can simply say we have an algorithm to decide answer is yes or no. That's why this problem is decidable. Yeah. Now let's go for a decidable language. So we have a problem. So problems in general they need not look like a language, but this problem is a language now. Basically, language is a set of members. The member can be a string, or member can be a machine, or member can be a grammar, something like that. So what is decidable language? Guys, if the language is decidable, if L is decidable, if and only if L has a TM and L complement also has TM. In the sense, this is the one definition I am giving first. You can also write another definition too. Both L and L complement are RE languages. If you want to say L is recursive, you have to show L is RE and L complement is also RE. If L and L complement both are inside RE, that is only one language that is possible, it is recursive. Maybe it's regular, maybe CFL, doesn't matter, but it is inside recursive class. Right? That means L is decidable in the sense, language is decidable in the sense L has a Turing motion that always halts. That always halts. So we have so many definitions. There is L is enumerable by TM lexicographically. Right? Yesterday I have used so many synonyms because decidable, another name only, recursive. Right? Recursive language only we are calling as decidable here. Yes or no? Now let's look at an example. Let's look at an example, guys. Suppose I have taken L is equal to Okay. DFA. I'm not asking question. And look at that. This is the language now. Language contain like DFA1, DFA2. We have a machines here. These are the members. These are our strings now. Every string is a machine here. What I am trying to ask here, I want the language that is set of DFAs, where each DFA accepts AAB. And how this is different from a problem, guys? In language we have valid members, right? Here if you are designing a machine for this, look at that. If you give any DFA here, as an input like a DFA1, DFA2 and so on, it can understand whether it accepts AAB or not, because if it halts at final, it accepts. If not, it will not. So it can say that DFA1 is valid member or not, right? It can say something. It can say something to you. What is that, guys? If that DFA, let's say I, any DFA you can give. If DFA I belongs to L, if this machine, this is the TM that accepts L, but what L has? DFAs. If that DFA is not in L, because it is not accepting AAB, DFA belongs to L means that DFA I accepts AAB. That is a valid member. Not belongs to L means DFA I does not accept AAB. And both sides we will have a logic, because if it is belongs to L, it definitely halts at final. Which one? This DFA halts at final. And if that DFA halts at non-final, it means it's not going to accept. Right? So both sides we have a logic, and both sides we will halt. So this kind of language is called as, good evening Sita. This kind of a language is called as recursive decidable language. This L is called as decidable language. But abhi to start nahi kiya, guys. Just I am talking about a definition, one example only. What is decidable language here? If and only if L is decidable language, if and only if for all W belongs to L, and for all W not in L, this both have logics. Means we will halt either string is valid or invalid. Here W is your machine. This is your W, guys. A DFA is your double input. So every machine, every member inside the language have a logic. Every member is outside the language also have a logic. Then that problem is decidable, because this machine, this TM always halts. So you can call this TM as halting Turing machine. And guys, most of the people are having a little bit of confusion about TM and STM. Guys, halting Turing machine is also a Turing machine, but that property of that Turing machine is always halts. Yeah, look at that. A single definition is also very important in this chapter. First I told word, now I'm saying definition. In future I'm going to talk about the problems. At any time you don't understand the problem, this definition is only the matter that will help you to solve the problems. Fine. So I hope you understood. What is decidable problem, what is decidable language. Everybody, so I'll make you a difference. Before starting the next one, I'm going to make you the difference clearly. What is decidable problem? Already problem language I have given a clarity. Now I am giving a clarity for decidability. Decidable language. Look at the difference. I will write the almost same. Here whether given DFA accepts epsilon like A, B, any string I can give. Right? It is a problem now. Here S sign no, if you are able to say the logic. Yes, you know how to say no. S means that given DFA all set final. No means given DFA all set non-final. You have CYK algorithm also. So anything that you want I will discuss later. But I am not discussing purely problems now. Only definition. Yeah, Ian. Yeah, Sumit, good evening. Now what is decidable language, guys? Decidable problem is clear, everyone? What is decidable problem? Now I'm going to talk about decidable language. It's almost looks like same, where I can say M. M is the machine. M is the DFA. M is DFA that accepts AAB. Now I'm not asking. I want to collect all the DFAs, but indirectly this decidable language depends on decidable problem. If that problem is decidable, this language is also decidable, because this exactly same as above problem only, right? If that problem is decidable, then this language is decidable. Here it is here one DFA only, here one DFA given, and we need to verify AAB is accepted by that given DFA or not. Right? But here it's not one DFA. Here we need to collect all DFAs, like M1, M2, M3, maybe infinite DFAs are there, we don't care. It's nothing but set of all DFAs where each DFA accepts AABB. Which doesn't accept, we don't collect it. But to collect this DFAs, you require the first algorithm only. The algorithm which we use here, whatever the algorithm we get. Understand, guys? Whatever the algorithm we get, we have algo exist. And the same algo we apply. The same algo we apply on every member, every input. The same algorithm we can apply on every input to collect the DFA which accepts A, B, B. Yeah. Right? All right. See that almost more than 20 minutes I'm trying to worry about have you understood decidable problem and decidable language. Because one example may not be sufficient, you require to practice many examples to stick to this definition. And decidable problem is different, decidable language is different. Language is a collection of members. Problem we say just yes or no, right? Yeah. The newly added topic in compiler design, you can study by searching on Google, or I will take that special session in on Unacademy. You can catch my classes, and in future I will also take on YouTube, but not now. But I'm already started this code optimization on Unacademy free classes. You can attend. Please visit my profile. Don't ask anybody. Just follow my profile. I'm going to take whole compiler also. Already revision started. Lexical analysis is over. Then I'm going to start syntax analysis tomorrow and go on. Within 10 days, the code optimization will be completed. So please follow that. Everybody, guys. And also do not forget, please like this session. You know how much it is important for us. And I know you are doing that. Yeah. Next one, RE but not recursive problem. We have two things, guys. Language is there, problem is there. You can consider as the problems or you can consider as the languages. Right? At the end, both are equivalent again. At the end, both are equivalent. Yeah. So what is this problem? If I have any problem, then why we say that problem is RE? RE means SD. Semi-decidable but not decidable. Remember, guys, semi-decidable but not decidable means you can say that undecidable, not decidable means undecidable only. Undecidable and semi-decidable, that is SD. Or I can say undecidable and partially decidable, but and both are same here, but partially decidable. Yeah, semi-decidable you can say or partially decidable you can say. And what is the meaning of this problem, guys? If the problem is decidable, you have halting Turing machine to understand that problem. Halting program is there. You can say that. Right? But when you say RE but not recursive, we will never have halting program. That's algorithm we don't have. Just we have a program. What is that means exactly? Suppose I have a problem. That problem is RE but not recursive. Like RE but not recursive. This is a problem name. You have some input. Let's say W. Right? It may be one or more, guys. Actually, I'm writing only one. But it depends on how many inputs are there. It depends on the problem. And if you are able to say yes as a logic, but no, you're not able to say, no logic exists for that. Okay. Logic not exist to say no. What kind of problems will have such things? Guys, what kind of problems where yes you can say but no you are not able to say? A very simple example I give. Today you are preparing for GATE. If I ask, will you crack the GATE exam? You will say yes. You will say yes because you don't apply the logic for not cracking the exam, right? A very simple example I am telling you that most of us are, instead of decidable, most of us are semi-decidable only, but not decidable, because we will always keep a logic for us. No, only some people will keep a logic. Yeah, good evening, Jai. So what kind of problem we have? If I ask a very simple question, guys, look at it. Whether given CFG is ambiguous, I'm not asking unambiguous. It's a problem. Which one will have a logic, ambiguous or unambiguous? Anyhow, it is undecidable problem. We can't have an algorithm for this, no algorithm for this, but we have a program for this. No algorithm, but there is a program. Remember that. Yeah. Which one has the logic? If you are saying yes, means CFG is ambiguous. No. If you say suppose CFG is unambiguous, but which one you can say? Unambiguous grammars or ambiguous grammars, you will have a confidence and you will have a proof. If the CFG is ambiguous, definitely some string as more than one parse tree, so that we can stop the algorithm. We can say the grammar is ambiguous, but can you say CFG is unambiguous? Can you say CFG is unambiguous? You can't, because every string generated by that grammar should have exactly one parse tree, right? You will never stop worrying about the strings, so that your algorithm, your logic never stops. Yeah, exactly. Don't say algo, Sweta, say the logic simply. Algorithm, we are looking for a problem now. Yeah. everyone? So by looking at this, who has a logic? Yes, as a logic, because definitely you can stop the sum only, right? I'm not worried about everyone. Some definitely you can find. Start with epsilon, try, do you have a derivation, because there is a CYK algorithm to verify epsilon, can you generate or not. So every string you can check, you can apply the CYK algorithm. CYK algorithm you can apply. So you can understand how many derivations are there for a particular string. If you get more than one derivation, guys, more than one derivation, then stop, say ambiguous. But if it is unambiguous, there's no way to stop, because logic not exist. There is no way to stop if the grammar is unambiguous. So this problem is undecidable. This problem is undecidable and semi-decidable, but it is definitely not decidable. It's not a recursive problem. You don't have alternate Turing motion. Only I can say TM exists, but no HTM. I can say program exists, but no algorithm, because algorithm always solves, but program no need to be. Yeah. Everyone clear? This is a RE but not recursive problem. Now, what is the language? This is about the language. Now, I am just taking the same example, but before that, let me design a language. This time, you give W, and this machine accepts, this TM accepts L. And if W belongs to L, then logic should exist. Then only we can say RE, but if W not in L, logic never exists. Logic not exist, you can say. Because we can't form a logic in general. In general, you can't. What example can prove this? Guys, yes, that is, you can say that this is S and this is no. Right? So previously, if you have looked at the problem, that's S in the problem. Here, member, right? Almost same, they are equivalent, no doubt. No doubt they are equivalent. S means belongs to, no means not belongs to, indirectly. So I'm trying to form a language, like, I have a CFG such that CFG is ambiguous. If it is not in L, so if I give any context-free grammar as an input, this is our W now. And this TM is accepting set of context-free grammar. And that CFG belongs to L, that CFG I, let's say CFG I belongs to L, means CFG is ambiguous. If the CFG not belongs to L, then CFG is unambiguous. Which one you can have a logic that always halts? Which side only? Only one side is halting. This side you have a logic. Because ambiguous CFGs you can identify, you can verify. But unambiguous CFG, there is no algorithm to verify why they are unambiguous. No logic exists. Definition is there, but no logic. So this is the main difference between problem and language. And I will just talk about what is the problem and language again. Guys, if I have whether given CFG, you are not constructing CFG. You are given, it's given. Chesh, that is decidable. यार पूरा खत्म करके आया फिर recursive पूछ रहा है. पूरा decidable पूछ खत्म करके आया ना. This is decidable. Decidable another name only recursive ना. कल क्या पढ़े हम? क्या यार दुनिया में कहाँ है? Recursive language another name only decidable. पूरा कल पढ़ के आया, आज definition दिया इसको. इससे पहले please go back to the video and you will know the definition. Yes. Do not ask the doubt which was already completed. Please go and watch. Whether given CFG is ambiguous. This is a problem. We will have yes or no. And who have a logic? If it is ambiguous means yes. This as a logic. and no logic not exist. If I look at a language, right, CFG, where CFG is ambiguous, this is not a problem. It's, you can call problem, but it's not just like a problem. It is a set of CFGs. It is a set of context-free grammars where each CFG is ambiguous. It's just like you have something like, S2, A capital A to capital A. This is a one grammar, guys. Let's say this is a one context-free grammar, comma. Other context-free grammar is like S2, SS or epsilon. And you have another CFG3. And so on. This is called as set of context-free grammars. This first one is called as a problem. Here only one context-free grammar is there. That grammar is ambiguous or not. And one grammar you don't have algorithm, then how can you collect this many grammars? That is the reason we say this problem is, undecidable and semi-decidable, because S only has a logic, and because of this L is also same answer. Language is also same answer, because this language indirectly depends on the same problem. Everyone, yeah, if you have missed previous classes, please go and watch, because without continuity, without regularity, this chapter cannot be understood, right? It's understanding of this chapter, you require continuity from the beginning. Fine. Is that clear what I have said so far? Now let me talk about not RE. Not RE means I have a problem, some problem, that let's say I have a problem, some problem is there. When you give an input, yes itself has no logic. Logic not exist. Over. Don't worry for no. Don't worry for no. If S has no logic, then that problem is not RE. Straight away. Straight away. Who will have S has no logic? Whether given CFG. Whether given CFG is unambiguous. Look at that, guys. Previously the question was ambiguous. That S was different. Now this time unambiguous. This problem, if I am saying yes, means CFG is unambiguous. Do you have a logic? No, may or may not, we don't care here. Don't worry about no. No, just leave it, ignore. Don't worry about it, because we are worried about the definition of not RE. This has no logic at all. Just now we have seen the no of the previous problem is S here. No logic at all. Logic not exist. Everyone? Anyhow, this is undecidable only, but it is not REL, not RE, not RE. But previous problem is also undecidable, because algorithm is not there. But that was RE, because at least S you are able to say. Everybody, guys, understand the two things, guys. I'm telling you again. What is, RE but not recursive, and what is not RE? Remember, this is also undecidable. This is also undecidable. Both are undecidable. For both of them, algorithm not exist. But here, yes, only S has logic. Here, that means no has no logic. Undecidable, yes has no logic. S has no logic. No, may or may not, we don't care. We don't care. Understand these two sentences carefully. Both are undecidable, but one is semi-decidable, the first one, who is having S as a logic, but no has no logic at all. Everyone, guys? Yeah. And why people say undecidable topic is very difficult? Because people directly trying to answer the questions without knowing the words. Look at that. If I want to say RE but not recursive, can I say directly? Already definition is too much. You need to understand what is yes and what is no. Then you need to think individually to answer that question too. Yeah. So not RE problem. What is not RE language? Very simple. You have some language. If you give any W, there's no machine that can do that. W belongs to L, has no logic at all. Has no logic at all. And W not belongs to L, we don't care. W not belongs to L, we don't care. Because I'm not looking for other definitions. Not RE, if I want to say, assume this is having L. If you give a W, if W belongs to L, has no logic, then that L, we can say not RE language. Example, L is equal to CFG such that CFG is unambiguous. There is no Turing machine for this because unambiguous languages have no logic at all. S only itself has no logic here, right? So this is not REL, not recursively enumerable language, and it is undecidable. But you can't say semi-decidable. Undecidable and not semi-decidable, you can say that. Not REL means not semi-decidable. Yeah. Guys, example also I'm giving, and I want you to look at that example, understand now, because in future if it will become complicated, I may discuss a number of problems. Guys, semi-decidable in the sense, it might be decidable or it might be RE but not recursive. It depends. Decidable RE but not recursive, the problem will decide. Either decidable or RE but not recursive. And I'm trying to give you RE but not recursive definition again. If you want to say RE but not recursive, how do you define, guys? I'm trying to define. L is RE but not recursive. You can simply say if and only if L has a Turing machine and L complement has no Turing machine. Because S only has a logic in L, and that means L is definition 1. This is a definition 2. L is RE, but L complement is not RE. It directly goes outside. Complement definitely has no logic for valid strings. Everyone, guys? Yeah. Now, when we say semi-decidable, that means that problem has a Turing machine, but we have no clarity whether you have altered Turing machine or not. Semi-decidable also called as RE problem, recursively enumerable problem, right? And language is same. It is also RE language. That means this language has Turing machine, no doubt. TM exists. HTM may or may not, we don't know. Right? Again, same. It can be either decidable or outside decidable. Who is there? Or RE but not recursive only within the RE. Either decidable or semi-decidable but undecidable. Right? And what is undecidable problem? It is either, you can say RE but not recursive problem. If this is not, then definitely that should be not RE. Any one of them is, you can call it as undecidability. Yeah. That means I can say that I don't have no HTM, no halting Turing machine exists. It means either Turing machine exists or no Turing machine, but no HTM exists. I don't have algorithm. I may have a program, I may not, but still the problem is undecidable because I don't have algorithm. I don't have algorithm. Either only S has a logic or S has no logic. Right? Undecidable language, same. It is either RE but not recursive language or not RE language. Not REL. It means again you can say that I don't have halting Turing version. Right? So these are the definitions, guys. Today we have learned what is decidable problem. So I'm just talking about decidable language. Problem, you can go and you can look at it. And RE but not recursive language. And not RE. These three are very, very important, because decidable language, in the sense, valid and invalid, both valid and invalid have a logic. Both valid and invalid strings members have logic. RE but not recursive means only valid strings have a logic. Invalid, no. Only valid members have logic. Only valid has the logic. Invalid, no logic. No logic. Logic not exist, you can say that. Logic not exist for invalid string, invalid members. For invalid. And not REL means logic not exist for valid strings, valid members. Invalid, I don't know. Invalid may or may not. Logic may or may not exist for invalid. That's okay. Yes. That is synonym. Logic, yeah, Vaishnav. Logic may or may not exist for invalid. It's okay. Bracket, don't worry much. Yeah. Guys, please remember, not decidable means what? It's a synonym of undecidable. Oh my God. Not decidable means undecidable. No doubt about it. But not decidable means not recursive, means there are two languages. Outside recursive, there are two types. One is within RE, outside RE. Within RE, which are not recursive, outside RE, you can say not RE. Not decidable. Anybody not aware of that, guys? Language. Look at the names. We have RE, we have not RE. In the RE, we have recursive and we have not recursive. This recursive, another name only, decidable, and not recursive, not RE, both are what? Undecidable. Undecidable, another name only. Undecidable, another name only, not decidable. And RE, another name only, semi-decidable. Everyone? So use the names carefully. Okay, so I hope you need to practice on these definitions. So tomorrow onwards, I will start the problems in undecidability. But anybody not completed today and yesterday classes, please complete them to attend the before class, to attend the tomorrow class, next class. Okay, thank you so much for attending today's class. And this is my daily schedule on Unacademy, including YouTube. And I will come back at 9 p.m. for C programming arrays portion. But I also have 7 p.m. Practice on today regular expressions. You can attend that session too. Okay, and also I'm taking 6 subjects revision practice at 7 a.m. every day. And every topic, one topic, I'm choosing CD and TOC to make a revision. Today regular expression is over, and merge sort is completed today in algorithms, and tomorrow most probably quick sort. And these are my regular classes on Unacademy and YouTube. You can follow me. You can follow me anytime to attend my classes. This is my URL to attend my classes on unacademy.com/@DevaGateCSE. Unacademy.com/@DevaGateCSE. You can follow me to attend my classes. Okay, we have so many educators, right? They are investing their time to teach you on this YouTube channel to increase our views, and please support us so that we can reach many students, right? Thank you so much. Thank you so much, and like the session before leaving. And if you are interested to take the subscription today and you have just half an hour time to increase the price, so you can use DEVA10 too. DEVALIVE is also my code. So use DEVALIVE code to get the subscription on Unacademy, and refer any of your friends who want to join. Thank you so much. Bye bye. Take care.